Okay, the next case we want to look at is what happens when we have a compound that does not contain a metal, that instead it contains two nonmetals. So now it's not held together by an ionic bond between a cation and an anion, because the nonmetals, when they form ions, all form negative charges. So they would actually repel each other if they were ions. So instead, in this case, we are looking at bonds based on actually the sharing of electrons. We'll learn a lot more about this in the second semester. But for right now, we need to understand that when we have two nonmetals bonded together, we cannot look at charge as to how to put them together. So we have to use a different set of rules for naming. The way we do this is we show the number of each type of atom by using prefixes. The common rule is that you can drop the mono prefix when it is on the first element in a compound. So if you have two nonmetals together and the first one only has one atom of that element, you would not name that with mono, you just drop the prefix. But all other prefixes must be used on both elements, the first and second, in the nonmetal compound. Greek prefixes we use: mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So let's look at examples of these. I think these are actually the easiest of all the naming that we are going to look at. Dihydrogen monoxide. So 2 hydrogens, dihydrogen, monoxide, 1 oxygen. The mono prefix has to be on the second element. If you see a mono, you can drop the mono on the first element, such as you see in these next two compounds, but never on the second element. Carbon dioxide. 1 carbon, monocarbon, we drop the mono, dioxide, 2 oxygens. Carbon tetrachloride, CCl4. Dinitrogen, trioxide, 2 nitrogens, 3 oxygens. You see the di prefix there. Anytime it's not mono, it must be included on the first element. Sulfur trioxide. Silicon tetrafluoride. A little bit more complicated going the other direction, just because you've got to recognize that you have two nonmetals in each of these cases. This case, when you're just looking at just these examples, it's not too bad. But when you're looking at a mixed group of naming, you always got to recognize anytime you see two nonmetals that you have to include prefixes. So diphosphorus, pentaoxide, diboron, tetrahydride. We still use the IDE ending at the end of the element. Carbon, we drop the mono, but you have to put the mono on the second element, carbon monoxide. Carbon tetrafluoride. Nitrogen trioxide. Dinitrogen monoxide. Dinitrogen tetraoxide. You can see from these last three examples that in all three cases you have nitrogen with oxygen. They come together in different ratios because they're not coming together based on charge. So that's why we use the prefixes to tell us how many of each atom we are going to have. So you must recognize anytime you have a compound that does not contain a metal, so has two nonmetals, you're going to use the prefixes with naming, but you only use the prefixes when you have two nonmetals. If there's a metal in the compound, there's no need for the prefixes and they would never be used.